Okay. So what we learned this year is called Algebra 1. And next year, if you follow the schedule, you're supposed to learn geometry. After that will be Algebra 2. Then after that will be pre-calculus, called pre-cal. And then calculus. Hello. Hi, Mia.
Hello,
How you doing?
good.
Yeah, we just got started. We're talking about like the schedule. Like if this is how normally, very typical in school. You go from uh, algebra one, then you go geometry, then go algebra two, then go pre-calculus, then calculus. And a lot of people took pre-calculus in junior year, and this is be sophomore. And this will be freshman, will be ninth grade. Ninth grade, 10th grade, 11th, and the 12th grade. That's normally that's how it goes. So when we learn Algebra 1, our focus is really on the rules of algebra. And we have been using it. But it's good a time because end of the year, it's good to actually do a review, make sure we are all uh, kind of reinforce our learning on the rules that we have learned. Because once you learn the rule, you basically can do whatever you can. Just like you play any sports, you got to know the rule. Once you know the rule, you can be as fancy as you can or as creative as you can, but it has to follow the rules. Okay, so the very basic rule we are dealing with in algebra has to do with the property of two operators. And one is addition, another one is multiplication. Sometimes we use dot because if we just use x and could be use this, can be confused with the letter x. So that's why in algebra we most time use the dot. Okay, and also the reason we're just dealing with two operators is because subtraction, uh, like say 9 minus 5, we can change that to 9 plus negative 5 because in algebra we have negative numbers. And again, the division, for example, 9 divided by 5, we can always write as 9 times 1/5. So that's why we really in algebra we are really as far as the rule goes, we're concerned just with those two. Okay, so what's our rules? Now the first two rules, it is called commutative commutative property, which means that if you have two numbers, the order has no matter. You can A plus B or B plus A. So the order doesn't matter. So for example, 4 plus 5 is the same as 5 plus 4. So that's the we call the property of addition. Just say when you add something, what does that do? So what's the property of that? So that's what we're doing here. Now for the multiplication, then similarly, the order doesn't matter. A times B is same as B times A. So that's the first two rules. Then the next set is associative property. And we have three numbers, basically A plus B plus C. Which two we got started? Well, because it's addition, then it really doesn't matter which two. You can go this two first, or you can have B plus C go first. Now, when we have a parenthesis, it means that we do that first. That's how the priority. Okay, and similarly, when we're dealing with multiplication. So it really doesn't matter which two we started. We can do the A times B times C, or we can say we'll do B times C first, then times A. So the order does not matter. So that's the associative property. And there is also called distributive. And we actually use that a lot. Just like when you have A times B plus C, and we can break that down into A times B and plus A times C. So that's called distributive. We got that. Okay. And we do that. For example, we have, say, 3x plus 2. If we want to find x, we have to separate them. So what we do is using this property. We got 3x plus 6. Now we can separate them. Okay, so the next one is, set is identity, called identity property. It has to do, basically tells us what we're dealing with two special numbers, 0 and 1. And later on, when you get high school, you will learn something called binary. And binary is a number that the computer speak, or computers speak. Yeah, 0, 1, 0, 1 basically, but 0, 1 is good enough to represent all the many numbers. Okay, but 0, 1 has a specialty. The specialty is that any number at 0 does not change its value. That's why we call identity. That's identical. Or a number times 1 give us A. Okay, so we have those. And the next one we got is called inverse property. Very important. Later we're going to see some examples. Is that a number adding its opposite is 0. So for example, 8 plus negative 8 is 0, or negative half plus half is also 0. So that's the things. Any number has its opposite. When they add them together, it gets 0. Or we talk about a number times its reciprocal. And this is the same as A divided by A. So that also is 1. And that's, any number has a reciprocal. So that's called inverse. And later on, we'll see why it's called inverse. Okay. And then we have something called the zero property. Zero property says that if a number times 0 is always 0, okay? But we cannot do this. We cannot divide by 0. This is called undefined. And we don't do that. But once we got to calculus, we'll see how can we dealing with something like that. Okay, we got that. Now, so the next one, this is the fundamental rules. Oh, give me 1 second. Okay, all right. So this is the fundamental rules of algebra. Okay, we're going to looking at, this is basically one group, one category of rules. We're going to looking at different groups of rules. Okay, so the next one is called order operation. And this actually, we learned that early on before algebra. That's when we did something called arithmetic. This is before algebra, it's called arithmetic. That dealing with add, subtract, and multiply, and divide. And we know the operation. And there is a short name for that, it's called PEMDAS. Now, do you guys remember PEMDAS? Okay, Mia knows. How about you, Grayson? PEMDAS?
What about it?
PEMDAS telling us the order. So the
Okay.
first P is
Parentheses.
parenthesis, right? P is
Yes.
parenthesis. That has the highest order.
Mhm.
And second one is exponent. E stands for exponent. And third one is M and D. That stands for multiplication and division. And lastly, AS is addition and subtraction. Okay, so that's actually is before algebra, but it's still useful here, is that when we add something, like for example, if we're dealing with things like 4 plus 3 times 2 squared, and we are not going to do 4 plus 3 because this is addition. Addition has no lower priority than multiplication, which here, which actually have lower priority than exponent. So all we're going to do is do the exponent first. So we still keep multiplication. And 2 to the second power is 4. And then now multiplication is have higher priority than addition, so we do that first. So 4 plus 12. Then we got 16. So, and we need this rule. Otherwise, people will get confused. Because if we don't know this priority, we can say 4 plus 3 is 7, 7 times 4 is 28. But that's not the correct answer, because this is a multiplication. We have to do that first. Good? Okay. All right. So that's our second group of rules. Or even though it's called 3, because our first was just introduction. So second is the basic operation and properties, and 3 is order operations. And 4, we are going to rules with when we're working with expressions. And there are two things we're basically doing. One is called combining like terms. Okay, that's when we're dealing with variables. Okay, so for example, when we have 7 and 4, they are like terms, they're all numbers. And so when we add, so we can add, subtract, multiply, and divide. Basically, we can just use the operation. Now, 5x and 4x, they are called like terms because they all have just one x. But if we have, say, 2x squared, now this is not the like term of 4x and 5x. It's a like term when we're dealing with, say, 7x to second power. So as long as this part is the same, they are like terms. Or you could have 5y plus 4y, they are like terms. But 5z plus 3x, they are not. Because, so we cannot just add them. We cannot say 5z plus 3x, what we're going to do? Is that 8z, or is that 8x, or 8zx? They're all wrong, because they are not like terms. So we can only combining them when they are like terms. Combining just means we add and subtract. Okay, are we good on this one with combining like terms? Okay, good. Grayson, we good with combining like terms? Okay, and the next is one thing we're dealing with expressions. Expression just means something without equation. Like for example, 4x plus 5, that's called expression. Or 2x squared plus 3x minus 9, that's expression. There's no equation there. Or we say 7x and 3s plus 5y, that's also expression. And when we have an equal sign, that means we have equations. For example, 3x plus 5 equal to 7, that's an equation. This set is expression, and this set is also expression, but we have an equal sign connect them. So the whole thing here is called equation. So, and for the expressions, we can have combining terms, or we call simplify expression, simplify expressions. So simplify expressions we want to combine. We're going to combining them until until the end. We cannot do anything about it. For example, 4x minus 1 plus 2. If we want to simplify it, we're going to say, okay, 4 times x is 4x. 4 times negative 1, negative 4 plus 2. Then 4 and 2 are like terms, so we can combine them. This actually is minus 4, which means the same as adding negative 4. So negative 4 plus 2 is negative 2. Now, once we get to here, there is nothing we can do anymore because 4x and 2 are not like terms, so we cannot combine them. So once we get n, we cannot do anything about it. So that's the end of simplification. And there are other type of simplifications. For example, 14 over 28. Well, we can say 28 is 2 times 14, and 14 and 14 cancel, we got half. So as long as we can keep simplifying it, we'll do that until we get n. On here, that's the end. There's nothing we can do anymore. Okay, so that's called simplifying expressions. Yeah, we good on this one? Thank you. Okay. Now we're looking at number 5, rules for equality. Rules equality just means for equations, the rule with the equations. Okay, there are actually there are several, but most of them, all of them actually we have done already. So this is kind of more or less a review and also know the terminology. So, for example, we say a number equal to itself. What is this property? And this actually is called reflexive property. Okay, reflexive just means we're talking to itself. Okay, and like, for example, the letter I and myself, that's reflective. Myself is a reflective, talking about me. Okay, so a equal to a number equal to itself. So that tells us what do we mean by equal. Okay, if you have same value, then they're equal. That's reflexive property. We also have something called symmetric property. And that is if, and you can see that very common. We use this if-then statement when we're doing algebra. If A equals B, and then B is equal to A. So that means symmetrical. When we say something equal to something, and we can just flip it. And we use that. Remember in past, if we got something like here, 7 equals 3x plus 1, we can say, okay, I like to have my variable on the left. So we can rewrite it as 3x plus 1 equal to 7. So this is the symmetric property we just used. Okay, then we have transitive property. And that is if A is equal to B and B is equal to C, then we can say A is equal to C. Good? Yeah, so it's A equal to B, then B equal to C, then A has to equal to C. Now, this is something like, say, if you want to check your height with your friend, well, you got the ruler, and you have your friend standing there, and you do a marker on the ruler, on maybe there is a wall, and you can put the height, and then you go over there, and you check. If you're exactly at the same marker, that means you and your friends are same height. Even though you haven't really checked with your friend, but you know that both of you on the same marker, so therefore you are the same. So this is the property we use. It's called transitive property. Okay, and the next one is called substitution property. And actually, we use substitutions when we solve system equations. Substitution property. And what that means is if A is equal to B, and then we can use B to replace A. Okay, that kind of looks a little bit strange. What that mean? Well, look at example here. For example, we have, say, 3y. Well, if we know y is equal to 2, then we can replace y with 2. So therefore, 3y will be 3 times 2. That gives us 6. So we replace y with 2 because y is equal to 2. So that's called substitutive property. We use that solving system equations. Maybe let's see if you can remember. If we have, say, x plus y is equal to 5, x minus y is equal to 1. So we know that x is equal to, from here, x equal to y plus 1. And then we're going to replace this x with this on the top equation. We got y plus 1 because the x is y plus 1, then plus y equal to 5. Then we got 2y plus 1 equal to 5 minus 1 on both sides. Or this is the property we just talked about. Then 2y equal to 4, then y equal to 2. So you can see that we use this property to solve our math problems. We're replacing the value because they are equal, so we can do that. Okay, and we got, this is very important. We actually use that a lot. It's called addition property. I just used that a moment ago. Is that if A is equal to B, then A plus C is equal to B plus C. That means we can add exactly the same thing on both sides of the equation. Doesn't matter what number we add as long as they are the same. Okay, next one, you can suspect it, is called subtraction property. That means if A equal to B, then A minus C equals to B minus C. You can see that we actually use that when we solve linear equations. For example, x plus 5 equal to 9. How do we know solve x? We minus 5 on both sides. Well, that exactly is our subtraction property. Then we got x equal to 4. So we do use that to solve equations. Okay. Now you probably have suspected that there is also called multiplication property. And that is if A is equal to B, then A times C equals B times C. Okay. And the last one is called division property, which basically is saying if A is equal to B, and we can divide by the same thing on both sides. As long as we divide by same thing, and as long as C is not equal to 0. Because remember we said we don't divide by 0. We call that undefined. I mean, it's something we just leave that when we get into either junior year or senior year when we're learning calculus, we're dealing with that. Okay, but now we can see, looking at an example, how do we use that property solving linear equations? Okay, for example, 3x plus 4 equals 13. What do we do? Well, first one, we minus 4 on both sides. That's our subtraction property. Then we got 3x and equal to 9. And then we divide by 3 on both sides. We got x equal 3. You can see that we use those properties. And those are the simple ones. And other things, we have to use addition property or multiplication property. But those are the rules when we're dealing with equations. Okay. Now we're going to looking at rules. Now, even though there's a lot of rules here, but since we have done a lot, we should be familiar with those rules. And as long as we are following the rules, we can do whatever we want when we're trying to solve math problems. And sometimes we can come up with a very clever way of doing it. Okay, so we look at 6. 6 is called rules for inequality. Inequality is when we're dealing with less than or greater than, sometimes less than or equal, or greater than or equal. Okay, and most time we're dealing with that because we don't need to have exactly amount of money to go to the store, as long as we make sure we have enough. Okay, all right, what is a property? So this is actually quite similar to our equality. And you can see that we got addition property. And that says if A is less than B, then A plus C is less than B plus C. So we can add the same thing amount on both sides. The inequality is still true. And that works not only with that, it works with add. For example, if A is greater than B, then A plus C is greater than B plus C. Okay, so we have that. We actually, for example, we use x, if x minus 2 less than 5, to figure out what x should be, we just add 2 on both sides, so x is less than 7. Now, this is different from equation. Equation, we only have one value, and this one we have infinite. X less than 7, it could be 6, 5, negative 10, or negative 140. Doesn't matter, but we just have infinite number of solutions to that. Okay, that's when we're dealing with, we have the addition property, and we also have subtraction property. That means if A is less than B, then A plus C is less than B plus C. Or if A is greater than B, then A plus C is greater than B plus C. So as long as we add the same thing on both sides, the inequality does not change. It's still true. Okay, now we have multiplication property, just like early on. Multiplication actually going to be a little bit interesting now. Now, it depends on what we multiply on. Now, if A is less than B, then now it depends on what C is positive or negative. Now, if C is positive, then A times C is less than B times C. And if C is negative, and that's where we have to flip it. A times C has to become B times C. Now the reason for that is because the nature of negative number. Well, let's see what's special about negative number. Now, this is 0. This is 1, and this is 2, and this is 3. So as it becomes bigger, we go to the right. And this is negative. Negative 1, negative 2, negative 3, negative 4, negative 5. So when we're going that way, that means since we have to be on the same number line, we have a rule here. We got origin here. But the rule here, anything on the left has to be less than anything on the right. Well, it makes sense on the positive side. 2 is on the left of the 4, and 2 is less than 4. But here, negative 5 is on the left of negative 3, so negative 5 actually is less than negative 3. Okay, and at the first, some people might get confused, but just think about we're going on the other direction. Okay, this is on the right, this is on the left. Okay, and anything on the left is less than anything on the right. Then that's basically how we set up this, we call this number line here. Okay, because that, if we say like 3 is greater than 2, but what happens if I times negative 2 on both sides? Well, if we go into negative 2 on both sides, what do we have? This side is negative 6, and this side negative 4. Well, negative 6 actually is less than negative 4. And you can see here, this is positive, the less greater than, the less than. Just because we multiply by negative 2, so we had to flip it. And that's something kind of special about inequality, we do that. If it's equation, doesn't matter, positive, negative, doesn't change the equation. But when we're dealing with inequality, we have to do that. Okay, now this is about multiplication. That same thing applied to division. So we can put them together. When we do the division, okay, if A is less than B, then A divided by C is less than B divided by C, as long as C is greater than 0. And if C is less than 0, we have to flip it. And C less than 0. Okay, we good on this one? Okay, thank you, Mia. And Grayson, are we good? I think it's... Hello, Grayson. His connection has a problem. Okay, this is one last property for the inequality is called transitive property. Yeah. Okay, transitive property is that if A is less than B and B is less than C, and then A is less than C. For example, 2 is less than 5, 5 is less than 7, so therefore 2 has to be less than 7. So that's what it means by this transitive property. And of course we have the same rule with greater than. So if A is greater than B and B is greater than C, and then A is bigger than C. Okay. All right. So now we can looking at some examples. So let's look at, we actually did on the linear equations. We just want to check check on the kind of review on the linear inequality qualities. Okay, so if we have 2x plus 3 is less than 9, again, we're going to minus 3. That's our subtraction property on both sides. So we got 2x is less than 6. Then we divide by 2. And because we divide by positive number, and we don't have to change this sign, inequality sign. But this is 2 and 2 cancel, then x is less than 3. Okay. Now we're going to looking at another example. For example, negative 3x plus 1 less than or equal to 7. Again, we can minus 1 on both sides. Then we got negative 3x less than or equal to 6. And if we're going to divide by negative 3, and that's where, well, this side, of course, they cancel. We got x. And this side is negative 2. But now, because we divide by negative, we have to flip that. So become x greater than negative 2. Okay, are we good on this one? Okay, great. All right. And we'll skip 7 today. And this is something you haven't learned yet. And you're definitely going to learn that in Algebra 2. Okay, we're looking at polynomial, okay? Polynomial. Polynomial is basically just means it made of 2 words. It's actually came from Greek. And so poly means many. Many. And nomial just means terms. Okay, so when we put together polynomial, it just means many terms. For example, 2x squared plus 3x minus 7. Now we got 3 terms. 1, 2, 3. And sometimes we could be a lot. We could be, say, x to the 5th minus 4x to the 4th plus 7x to the 3rd and plus 2x to the 2nd and minus 9x plus 1. Then we got 1, 2, 3, 4, 5, 6 terms. So that's all called polynomial. And also about the variables. Variable has to be either x or x squared or x to the 3rd or x to a positive to the numbers. So, and it could be 5, 6, 7, 8, and could be many. But as long as it's x, one variable, and have exponent on that, and has to be positive exponent for the polynomial. And you're going to learn that in Algebra 2, there are different kinds of things. But Algebra 1, we pretty much just do work on the polynomials. Okay. All right. On the polynomials, of course, we are doing with hello. We can add and subtract. Now, for example, 3x squared plus x minus x squared plus 2x. Now, of course, first thing we're going to open up the parenthesis. So 3x squared plus x, and this one minus, so we got negative x squared minus 2x. And then we can combine like terms. This and this are like terms. So 3 minus 1, because it's you can think about this is a 3 apples and minus 1 apple. We got 2 apples. And we can think this one as bananas. And 1 banana minus 2 banana. This means we owe someone 1 banana. So we got 2x squared minus x. So this is about add and subtract. And we also can multiply polynomials. For example, x plus 1 times x plus 2. Well, what would that be? Can we simplify that? Well, we know that we can use distributive property. So basically, we're going to distribute x to this one. We got x squared, because that's what x squared means x times x. Then x times 2 give 2x. And then we got this get distributed is x, and times 2 is 2. And now we can combine 2x and x. So we got x squared plus 3x plus 2. Okay. All right. Well, we know we can add, subtract, and multiply, and we can actually also divide. Because, like, say, 4x divided by x, that's just 4. And 5x squared divided by x, it's just 5x. Yeah. So we also can divide. And there's one more thing, it's called factoring. We can also do factoring. Factoring, for example, 6x squared plus 9x. Well, we know we can move x out. We got x, 6x plus 9. Well, notice that 6 and 9 have a multiple of 3. So 6 is 2 times 3 times x. And here is 3 times 3. So 3 is common. We can move 3 out. So we got 3x, and we got 2x plus 3. So we can, so this is kind of the reverse way of distribute. If we're going to distribute, then we go from 3x, 2x plus 3, we distribute it. That gave us 6x squared plus 9x. That's called distribution property. And the reverse is called factoring. Okay, that's what when we do factoring is. We just go the reverse way, and depends on the problems. Sometimes we need to expand it. That's using distributive property, and sometimes we need to grouping it is using the factoring to group them. Okay, so we have that. Okay, so that's for the polynomials. And polynomials, we have, there's a couple of things. Actually, it's not there. I'd like to add on to it. Oh, do they have it? They probably have it. Nope, they don't have it. They should add to it. So what I'm going to add to it is that when you have something like this, a plus b squared, and you expand it, you should have got a squared plus 2ab plus b squared. Now, if you don't remember it, you can always expand it. But of course, it's good to memorize this. And to be able to derive it, that can help you to remember. So a times a squared, a times b is ab, then ab times a, well, we know b times a is the same as a times b. That's our commutative property, then we got b times b squared. So we got a squared plus 2ab plus b squared. So that's what we got here. Okay, and another one is very useful, is when is called the square of difference. This is called square of sum. Square difference is a minus b squared. That will give you a squared minus 2ab plus b squared. Now again, if you want to remember it, it's a minus b and a minus b. That's what a minus b squared means, right? The exponent means the base. This is called the base. Means the base multiplied itself by twice. Then we can use distributive property. We got a squared, and that times that negative ab, and this times minus ab, then negative, negative, positive. So that's why it's add. Or that gave us a squared minus 2ab plus b squared. Okay, so we have that. Now, another way to help us to remember is that looking at a minus b squared is basically a plus negative b squared. Now we can use the top one formula that gave us a squared plus 2a times minus b plus negative b squared, and of course is a squared, and positive, negative, get negative. So negative ab, the negative square is positive, got b squared. So basically we can use this formula to derive the second. Okay, there's another one which is very important, is called difference of squares. Okay, so this is called square of sum, and this one is called square of difference. Then we have it called a squared minus b squared. This is called difference of square, and that is equal to a plus b and a minus b. And this actually got used a lot in algebra. And the same thing, we can actually verify it. Well, can see a plus b times a minus b, same thing, distribute it. It's got a square. This times that, negative ab, and this times that, ab, and then b times negative b is negative b squared. Okay, but we say negative ab and ab cancel, we got a squared minus b squared. So therefore we have that. And this is actually quite useful when we solving math problems. Okay, are we good on this one? All right, very good, very good. We learned how to graphing linear equations, and I think you guys are fine with fractions. And we're going to looking at the system of equations. We have done that before, and here we're going to just quick review on that. Okay, for example, what we got here is y minus 2x equal to 0, and the other one is x plus y equal to 6. Now this is called systems of equations. Well, we call it system because we got two equations, top one, bottom, two equations. And in this case, we got two equations, we got two unknowns. One is y, one is x. But this y and this y, this y and this y means the same variable, and this x and this x means the same variable. So now, how do we solve that? Well, remember the rules we got here. We know we can add, we can, we have addition property and abstraction property. We can, the substitution rules, we have that. So what we're going to do is, in order to solve that, we got two unknown. And so the thing we're going to do, our strategy, is that turn that into one unknown problem, okay? Because we know how to do one unknown. So we change those two into one, or we can say two variables into one variable. Okay, so what we're going to do here is, based on this equation, we can rewrite as y equal to 2x. That's very good. So we establish equality, y is equal to 2x. And then we use substitute property to substitute y with 2x and to this equation, because we came from this equation and we cannot go back. So we have to go to the different. So we got x plus 2x equal to 6. And then combining like terms, 3x equal to 6. And then we divide, right? We have division property. And then we got x equal to 2. And then we're going to back to find y. Then we substitute, again, substitute property. And so y is 2 times 2 give us 4. So that's how we're solving it. Now, this is called substitution, okay? Because we substitute one variable with another. And there is another, okay. And there is another way of solving system equations. It's called elimination. Now, both substitution and elimination have the same strategy, is that we're going to change that from two variables and into one variable. And then we solve that. Then we go back to solve the other. So just make things become easier. That's basically the common strategy we have if we want to solve something, especially something that are difficult. We just break that into smaller problems and break them into easier problems. Then we solve those easier problems. Once we get those done, we basically solve the difficult problem. Okay, so let's look at x plus y. This is a pretty simple one, equal to 5, and x minus y equal to 1. And we put them together. Okay, so elimination is we're going to get rid of one variable. What we're going to do is, if we add this equation, our first equation, to the second equation, and this basically is our addition property. Remember, if a is equal to b, then we can a plus c is equal to b plus c. So let's say we know this is true, x minus y is 1, but we're going to add this on one side, so add x plus y. On the other side is 5, because x plus y equal to 5, then we can do that, because this rule tells us as long as we add same amount on both sides, the equation is true. So therefore, we're going to add x plus y on one side, then 5 on the other. Now, if we do that, x plus x, 2x. Negative y plus y, cancel. That's why we call elimination. That y got eliminated. And that will be equals to 1 plus 5, 6. Then we divide by 2. And we got x equal to 3. Well, we find x. We have to go back find y. So what we can find y, we can either use this equation or use that equation. It doesn't matter which. So I'm going to use the first one, for example. So Then we're going to use substitution because we substitute x with 3 because x equal to 3. So this equation then becomes 3 plus y equals to 5. And then we minus 3 on both sides. What we got is y equal 2. So we find those two. And there is one last step, is always important, is to verify it. Okay? That's how we can check if we got right. So what we're going to do is we plug in. We now say our x is 3, y is 2. Well, we plug into first one, see if that match. Okay, x is 3, y is 2, 3 plus 2 is 5. So we're good on the first one. The second one, x is 3 minus y is 2, that equal to 1. So therefore, that is also good. So therefore, we know our solution is good. All right. Are we good on this one? We good? Okay. Christian is good. Mia is good. Okay, wonderful. So I'm going to send you some homeworks you can do, and our next week will be our. Let me see. I think we still have 2 more weeks. Yeah, we got 2 more weeks, and then we're going to talk about if you have problem with the homework, and also we're going to looking at the things we learned the last one with the quadratic equations. Okay, so that probably needs some review on that. Okay, are we good on this one? All right, I'll see you guys next week. Bye. Hello? How are you doing? Okay.